Okay, it is time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic is going to be database foundations in NoSQL. So before we start today, there's a couple things I'd like to mention. The first one being is that we're going to stop periodically throughout the lecture to open the floor for questions. So if you do have those come up along the way, we just ask that you wait until those designated times to ask them. Another thing to mention is that we're recording this lecture. So once we're done here, we're going to be posting it on our YouTube channel. We're going to make that link available to you in your student dashboard. So diving right in, let's go ahead and discuss what topics we're going to be focusing on today. And the main topic will be NoSQL. So let's go ahead and start off by talking about what is a NoSQL database. Okay, and in its simplest form, a NoSQL database is a database that allows the insertion of data without a predefined schema. Okay. So if you've ever worked with traditional databases, with SQL-oriented databases, you'll know that it's the opposite approach. Normally, you would have to create a data structure within your database, normally called a table, and tell it what to expect. But now, using NoSQL, it can just adapt to the data it sent. Okay, so the provider we're going to be using today for our NoSQL database will be MongoDB, and then after you install this on a machine, we're going to use the Mongo shell to connect to a cloud database. The cloud database we're going to be using is called MLab. So if you don't already have one, you're going to need to sign up for an MLab account. And then afterwards, let's start by creating a new database. We'll select AWS as the web cloud provider and Sandbox as the plan. From here, we'll select the region nearest us, and we will select the database name. Okay, I'm going to submit and let it process. Okay, so now that that's complete, we can go to our awesome DB. And from here, let's go ahead and go over the structure here. Okay, so first we got something called collections. And collections are different categories of data within our database. So you can think of things like users collections, movies collections, that kind of stuff. Then within each collection, you have individual records known as documents. And each document is represented in JSON format with a key value pair sequence known as a field. Okay, and so next tab we have is users. And users allow us to set up database users to have access and permission to this database outside of our regular account user. So I'm going to go ahead and add one. I'll call Isaac with a password of 123. Okay, next tab we have is stats. And as you can see, it just reports on the stats for this database. We have backups, very good idea if you have anything in production, in case anything happens to you, you have your data backed up. And then tools for import export to CSV and all that good stuff. Okay, so now we understand what's going on in our account here. Let's go ahead and connect to this database using the Mongo shell. The Mongo shell is a command line tool that's installed as part of the Mongo installation. So let's go ahead and copy that, open up our command line here. Okay. And next, let's go ahead and let's run the script. Okay, except this time, let's change out the placeholder DB user and DB password for our actual database user and password we just created. Okay, so as you can see, I'm now connected to the Mongo shell. So by being connected, I can now perform different operations within my database. Okay, and the most common kind of operations you're going to be performing in regards to a database is called CRUD, and that is create, read, update, and delete. So let's go ahead and let's learn how we can use the Mongo shell to perform these operations. So let's first start with creating or inserting this data into our database. Okay, so to do this, let's go ahead and add a cars collection, and then we'll insert cars documents into that collection. Now we're going to do this. We'll say db.cars.insert1, and the car type we'll insert is Tesla, and we'll make the year 2017. Okay, as you can see, acknowledge is true. So if we refresh here, we can see that we have the cars, just how we set the type of year, and then it automatically generates a unique ID for each document. Okay, so let's go ahead and set up a couple more cars. So same approach, we'll say db.cars.insert one type of car, we'll say as Mercedes, and the year will be 2000. Oops. Let's try that again. So we will say type of car is going to be Mercedes. Okay, and the year will be 2000. Okay, now let's just do one more car. And we'll do type BMW and year 2006. Okay, if we refresh, you can see we now have 3 different cars, and they're all different years, right? And the idea is keeping them unique. Okay, so now we know how to create data inside our database. Let's learn how we can read this and retrieve this data. Okay, so first let's learn how we can just get all documents in a given collection. So to do this, we say db.cars.find, and we just leave an empty filter there. Okay, and then as you can see, it returns all the cars from that given collection. Okay, so now let's learn how we can filter out the cars by equality factors. So I'm going to say db.cars.find, and then I'm going to find the car whose type, and we'll use the equal to operand. And we'll say Tesla. Okay, and as you can see, it only queries one document from our collection. It's a document with the type of Tesla. Okay, so now we know how to query by equality factors. Let's go ahead and learn how we can query using comparison operators. Okay, so let's say we want to find all cars greater than the year 2005. Okay, so to do this, we could say db.cars.find, and we could say year. We could use the greater than operand. We could say 2005. Execute. Okay, and as you can see, it only returns 2 documents, right? It's a document with the year 2017, 2006, which are both clearly above 2005. Okay, so let's go ahead and do this in the opposite order now. Let's go ahead and find the cars with the year less than 2005. And you can see now it's only returning 1 document. That's the year with the car with the year 2000. Okay? Next, let's learn how we can query documents using logical operators. Okay, so let's start with AND. So maybe we want to combine a couple comparisons in one single query. Now we can do this as an AND operator. So what I'm going to do is I'm going to say db.cars.find, and I'll throw in the AND operand, which will take an array of different conditions. So we'll say year is greater than 2005. And the year is less than 2010. Okay, so we can see only 1 document was returned this time, and that was the car with the year 2006, because it's the only one whose year was greater than 2005 and less than 2010. Okay, so that's how we can use the and operand. Now let's explore the or operand. Okay, so let's say we want to find cars with the type of Tesla or Mercedes. So to do this, we could say db.cars.find, pass in boolean or, and this will take a set of conditions. Okay, so we're going to say type equal to Tesla or type equal to Mercedes. Close the bracket. When we execute it, we can see that it only returns two documents. Document with type of Mercedes or Tesla. Okay, and that's how we can use logical operators. So let's go ahead and let's move on to the topic of projections. So whenever we're dealing with queries, we oftentimes are going to be targeting a specific field a lot. Okay, and if that's the case, and that's the only information we need from the entire document itself, then we can use a projection. So how projections work is we only query the information we need and not the entire document itself. So let's say I want to query all the cars, but I only need the name of the car and I don't need the year. So how I can do that is I can say db.cars.find, and then I'll put in type as 1, which will signify true. Okay, so as we can see, it returned the type, but it did not return the year, right? So now, if we want to give them more fine grain, we could request to leave the ID off even if we wanted to. So we can say db.cars.find, type 1 colon underscore ID 0. Okay, as you can see now, using this projection, we are only querying the bare minimum data we need, which is going to definitely lead to performance boosts in our app. So that is a projection. So now we've got a pretty good idea of how to query and request document information, and also how to insert that into the database. Let's learn how we can update and remove it if needed. So let's say we want to change the Tesla from the year 2017 to the year 2018. So to do this, I'm going to say db.cars.update. Okay. Now I'm going to pass in the car with a type equal to Tesla. Okay. And then I'll use boolean set to set the year to the year 2000. Year 2018. Okay. Comma here. Upsert equals true. Invalid property ID. All right, so let's try this again. db.cars.update 1 type Tesla. Set year 2017. Upsert equals true. Okay. So let's see here. Refresh. Oh, it looks like I kept the year the same in 2017. Let's try this one more time. And so my syntax is right. I just need to modify the year to 2018. Okay, so now that went through, let's refresh. And as we can see, we've updated it from the year 2017 to the year 2018. Okay, so now we know how to create, read, and update data. Let's go ahead and learn how we can remove it. Okay, so to do this, I'm simply going to say db.cars remove delete one. And we'll delete the car with a type equal to BMW. Okay, so now we come to our database and refresh, and we can see we only have 2 cars remaining and the BMW has been removed. So now we have performed full CRUD operations on our database. Okay, so let's wrap up with the topic of one-to-many relationships. So one-to-many relationship is just how it sounds. It's when you've got one piece of data that's related to many others. A very common example of this is Yelp.com. So if we go to Yelp, we can see that we have one category associated with many places. Okay, so let's just type in food here. Okay, and it's going to find all the places, right, associated with one category, and that category is food. Okay, so let's do a similar approach in our own database by starting off and creating a places collection. Okay, so now to create one-to-many relationship between a place and a category, I can simply do this. I can say db.places, insert one, and we'll start with the first place. We'll give it a name, Disneyland, and we'll give it a category. And we'll say entertainment. Okay. So now we've got one. Let's go ahead and add a couple others. Say places.insert one. Name equals Universal Studios. And category is the same. It's going to be entertainment. Okay, so one last place here. Let's actually make this place different kind of category. So we'll say name, say in, out, per, and we'll say category equals food. And enter. Okay, so we come back and we go to places, and we say we have 3 different places, except they have different categories, right? So now we've created a one-to-many relationship between the category and the place. So if I wanted to query all places associated with entertainment, I simply would have to say db.places.find category entertainment. Okay, and as you can see, it only returns 2 documents, right? And that is my 2 places with actual entertainment. And same goes for food, right? So if I say db.places.find category equal to food. Now I'm only getting 1 document returned, and that's the document associated with category food. And this is how you can set up a one-to-many relationship inside your NoSQL database. So let's go ahead and let's open up the floor and let's see if anyone has any last questions before we end today. So the floor is open. If you have questions, feel free to ask those now. All right, I don't hear anyone. Going once, going twice. All right, we're out of here. Thank you everyone for stopping by. Have a great day and happy coding out there.